Hello everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics, IARE. The subject we selected for this video lecture is Probability and Statistics. The topic is Test of Significance for Single Proportion. One of the main we are going to focus is definition of population and sample and test statistic for our topic single proportion, the limits of population proportion, how to calculate. That is also in detail we are going to discuss. So many problems also we are going to solve. First, what is the definition of population? Which one we will call it as population, and what is the difference between population and sample? A large collection of individuals or numerical data is called a population. A population may be finite or infinite. If it is, what are the members, what are the individual it contains, what it has. If it is possible to count, then it is finite population. If not, then it is infinite population. That's what it is given in the paragraph. Sample. Sample, it's nothing but we can call the sample is a subset of this population. A small group of data we are collecting from population to analyze the statement which is defined in the population is correct or not. So a part of small section selected from your population is called sample. Then sample itself, two types are there, small sample and large sample. How to differentiate it? If the size of the sample, which is denoted by small n, then what about the population size, that is capital N? If the samples we are collecting from the population, if it is less than 30, we will call it as small sample. If it is greater than or equal to 30, then we will call it as large sample. The process of selecting a sample is called sampling, and the relationship between the population and samples, the samples which are drawn from the population, is called sampling theory. More to understand very clearly, a good example. Now we want the academic status of engineering, the total engineering colleges in Telangana. So that is a population, that is total engineering colleges in Telangana is population. Then to analyze that, few samples we are going to get. That is few colleges we are going to select. That is one of the sample is Institute of Aeronautical Engineering. So the sample is IARE, and all the total engineering colleges in Telangana is population. So IARE is a subset of Telangana Engineering Colleges group. So now the critical values of Z. So what is the usage of this critical values of Z? We have to take a decision whether what is the statement defined of the population is accept or reject. Here the level of significance is 1%, here 5% and 10%. The critical values of two-tailed test, that is the normal curve under which the area, the always total probability is 1. So the area which is spread on the normal curve, here mod Z alpha, that is minus 2.5 to 2.58. So between that the area is accepted. The two sides of shaded regions are rejected. So that's what here we are going to discuss while solving the problem. These values, the tabulated values, they are playing a crucial role to take the decision to accept or reject. If it is one-tailed test, that is, these two are called one-tailed test, in which the shaded region which falls on right side, then right tail test. If it is on the left side, it is left tail test. So the first problem, a manufacturer claimed that at least 95% of the equipment which is supplied to your factory conformed to specifications. An examination of a sample of 200 pieces of equipment revealed that 18 were faulty. So the first thing here, at least 95%. The manufacturers is manufacturing so many equipments from the factory. That is the specifications. That is 95% we can confirm, we can tell they are good. They are fit for the specifications. Population, about the parameter, about the details, the information which are given there. Whether it is correct or not, to check, we have taken 200 pieces. Out of 200 pieces, the checking, we found that 18 were faulty. Here, this is only very important thing. 200 samples we have taken, in which 18 were faulty. Then how many are good? How many are confirmed for the specification? So 200 minus 18, 182 are good for confirmation. So the test this claim at 5% level of significance. So now the data here which is given about the population, detail, information, 95%. This 218, we need a proportion. That is 18 divided by 20 means the proportion of faulty it will come. We need confirmed specifications data. Then 200 minus 18. So we have to read the question, what we are asked to do it regarding that data we have to pick. So the solution we are moving, n equal to sample size equal to 200. That is 200 samples we have taken. So number of pieces conforming for the specification is 200 minus 18 equal to 182. Sample proportion. So 182 divided by 200, 0.91. The sample proportion, which is denoted by the symbol small p. Sample size is small n. Capital P is population proportion. This fraction, how we got it? The question, the first sentence itself, which is given 95% of the equipment, their confirmation to specification. So 95%, it's 0.95. Now capital P, we obtained it, that is 0.95. Then capital Q is nothing but 1 minus capital P. So the Q 0.05. Why here capital P is the thing? Why we have to find what is the need, what is the requirement for finding this Q? Because the test statistic in which there is a term Q, it is there. So when the Q is dominating in the test statistic formulation, to substitute in advance, we are finding the value of Q. So the first one is null hypothesis. That is null hypothesis, the symbol H0. About the population, the information we will define on null hypothesis, that is capital P equal to 0.95. 95% of the equipments are fit for confirmation to specification. But the second one we will reject. Because how we are rejecting less than? Because why here specifically we have to select less than? The previous slide, the sample proportion we noticed it, that is 0.91, the data we obtained it. That is, it gives an indication that the samples, what we obtained, the result is less than the population proportion. So that is the main reason also we can see here we selected less than. Here the H1, it is there, alternative hypothesis, that is capital H1. So left-tailed test we adopted here. The level of significance is alpha equal to 0.05. Now the 0.05 left tail, what is the tabulated value? The starting of this video lecture, the critical value of Z, the slide we discussed it. That is, yes, this is the one from which now we have to pick P less than 0.95. Thus, alpha equal to 0.05, the level of significance. Here the less than is there. So left tail we selected, and 5%. Here the value is minus 1.645. So the level of significance at alpha equals 0.05 is 1.645. The test statistic is small p, that is sample proportion, minus capital P, population proportion, divided by square root of PQ by N. So that is here capital P, here capital Q. Here the Q is playing the role. That's what in advance we calculated the value of Q divided by N. So all the values are available with us now. So we are substituting, that is small p 0.91, capital P 0.95, again square root of PQ, that is 0.95 and 0.05, N place 200. So simplifying, calculating, then we obtained the fraction minus 0.04 divided by 0.0154, that is minus 2.59. So mod Z is nothing but modulus of minus 2.59. It's nothing but 2.59. So the tabulated value of Z at 0.05 level of significance is 1.645. Here one doubt is ringing. So yeah, we are getting the doubt because the critical value of Z, there minus 1.645 is there, but here we didn't write minus sign. Always we will take tabulated the values. Tabulated values in the sense that is the values we obtained from the table of the critical value of Z, that we are naming as tabulated value of Z. Modulus we are finding. Always we should find modulus. Then again one more doubt. What is the need of that minus? Right tail in the list we have seen it. That is also positive. Left tail minus sign is there. In the minus sign, that is also we are taking modulus. Then there is no difference at all. Another one more doubt is coming. Here, that the critical value of Z, the negative sign, which helps us to indicate which direction the point to be focused, whether left side or right side. That purpose, the negative sign. Because we know it always, the area will be positive to any particular point. So the calculator of Z, coming to our current problem, what we are discussing, that is the current value of Z is 2.59. So the tabulated value is 1.645, whereas the calculated value is 2.59. Tabulated value, if it is more than what we defined on the null hypothesis, is we have to accept. But this problem, the tabulated value is less than the calculated value, that is 1.645 is less than 2.59. So hence the null hypothesis H0 is rejected. So we can see it, this is the starting stage of normal curve. So the next development of the curve is, here we can minus Z alpha to, yes, here only this point minus Z alpha. Yeah, just now we have told that the negative, the sign which denotes the tabulated value in which direction. Here the left side of this symmetric line. That is this line, the vertical line which divides the area under the normal curve equally. This is 0.5 area and this is 0.5 area. Here our tabulated value, that is 1.645, is there, but calculated value is 2.59. We can see it very clearly, the final output of the graphical representation, which region is accepted and which region is rejected. Here is our 1.645. Our calculated is 2.59. Naturally, it falls in this side. Here, this is also 0 to completely, it is a 0 to infinity positive point. The two sections, if it falls, it is accepted region. So here we are noticing that. Yeah, 1 minute, we can see it. Yeah, yes, we can see it now. So this is we can see it here, our accepted and rejected regions. It is a left-tailed, the graphical representation with a marked, the arrows are marked. Here, that 2.59 is our calculated value. Our tabulated is 1.645. The tabulated value is less. That's what the null hypothesis H0 is rejected. Here we can see our problem. Yes, this is our question. That is 95%. Particularly in this problem, we selected the left-tailed because the sample proportion here 218, 182 divided by 200, we got it 0.91, whereas this is 0.95. So we selected the left tail and the rejected persons. Null hypothesis, we defined capital P, that is population proportion, which is equal to 0.95, rejected in such a way, taking left tail. So the null hypothesis is rejected. So the second problem is, in a big city, 325 men out of 600 men, that is 600 men we are taking, in the 325 men were found to be smokers. Does this information support the conclusion that the majority of men in the city are smokers? So question is now, proportion we have to pick. 600. In that, out of 600, 325 men are smoking. So n equal to, that is a sample size, 600. So the next one, number of smokers, 325. sample, the small p, sample proportion, that is 325 divided by 600. So 0.5417. That is the output we got it for sample proportion. Population proportion is, here it is not given about, only the information about sample proportion is there. So here in the society, that is smoking person, not smoking persons regarding men. So equally we are population proportion we are taking, that is 0.5. So the capital P, and we need capital Q also, because the test statistic is small p minus capital P divided by square root of capital PQ divided by N. Now we can see it here. Null hypothesis, that is we are accepting that is capital P equals 0.5. H naught is the symbol. We are telling that is the population proportion. Smokers and non-smokers both are equally, that is 0.5 we have taken. We rejected in such a way that capital P is greater than 0.95. I think so here the data which is wrong. It is 0.5417 here. This data to be here, that data should be written here. Yeah. So the level of significance alpha equal to 0.05. So we can see it, this is a right-tailed test. Yes. And here 0.5. So 1.645 is the value of it. The test statistic is small p minus capital P divided by square root of PQ divided by N. Yes, here it is small sample proportion, that is 0.5417, capital P 0.5, and here capital P 0.5, capital Q also 0.5, because 1 minus capital P it's nothing but 0.5. 600 men we selected as sample size. So now which is equal to 0. The numerator, the calculations we got it 0.0417 divided by the denominator is square root of 4.17. So that fraction 0.0417 divided by square root of 4.17, it's nothing but 0.0417 divided by 0.0204. The final output is 2.04. So the tabulated value of Z at 0.05 level of significance is 1.645. Calculated value is 2.04. So the tabulated value, that is this 1.645, which is less than the calculated value 2.04. So the null hypothesis, always the null hypothesis, if we have to accept, the tabulated should be more, but here the tabulated is less. That is the reason the null hypothesis H naught is rejected. So we can focus that now our bell-shaped the normal curve which is ready. Then we selected here in this problem the right-tailed test, that is what Z alpha, which is placed the tabulated value on the right side to this symmetric line. So the final, the output of presentation graphically we can see here with the accepted and rejected region. Yes, this is the rejected region, accepted region for the right-tailed test. Yes, here we null hypothesis, we defined P equal to, here this is the data, 0.5. That is, P equal to 0.5 we have taken, but we rejected in such a way taking right-tailed test. But here the right, why it is rejected? Because our tabulated value is 1.645, which is less than the calculated value 2.04. Yes, this is the question. This is 0.5 population proportion. We have to accept it. We defined our null hypothesis capital P equal to 0.5 and we rejected in such a way taking right tail. Then why we rejected? Because the tabulated value is less than the calculated value. So the next one is the third problem. In a sample of 1000 people in Karnataka, 540 are rice eaters and the rest are wheat eaters. Can we assume that both rice and wheat are equally popular in the state at 1% level of significance? So the sample we have taken 1000 people. Yeah, the sample size is there, N. We obtained the data from the question. 540 are rice eaters. Then the remaining, the leftover, that is 1000 minus 540, the remaining the people are wheat eaters. Equally, that is the population generally about the state they are telling, equally rice and wheat they will be eating. Equally in the sense, we know it is 0.5 and wheat eating 0.5, rice eating also 0.5. N equal to sample size 1000. Small p, that is sample proportion. We are focusing on rice eaters. So the rice eaters, here another one doubt. Why we have to focus on rice eaters? Why not wheat eaters? Any one small proportion, that is rice eating we have taken 540 divided by 1000, that is 0.54. So sample proportion which is ready now. Now we have to move to population proportion. So the population proportion is here, that's what, here the data which is not given but equally popular they told. Mathematically equally 50%. That is for the wheat purpose 50%, for the rice eaters 50%. So 50%, so the decimal 0.5. Now we have to define our null hypothesis keeping in our mind population proportion. And Q also in advance we are finding to substitute in the test statistic formulation. So 1 minus capital P. Capital P denotes population proportion. So 1 minus 0.5 equal to 0.5. So the null hypothesis, with the symbol H naught, we defined capital P equal to 0.50. That is, we defined in such a way that rice and wheat eating persons equally popular in that particular state. No, they are not equal. We are rejecting in such a way that H1 colon P not equal to 0.50 two-tailed test. And specifically it is given in this problem the level of significance 1%, that is 0.01. Yes, our critical values of Z table is ready. Now two-tailed test, here it is there. Then 1%. What is that 1%? 2.58. So the level of significance at alpha equals 0.01 is 2.58. The test statistic is Z equal to small p minus capital P divided by square root of PQ by N. So the respective places we can substitute the data here 0.54, that is a sample proportion, and population proportion 0.50 divided by PQ. They are taking the values as 0.5 and 0.5, whereas N is 1000. The fraction what we obtained is 0.04 divided by 0.0158. The final result is 2.531. Mod is that we are finding, that is 2.53. So the tabulated value of Z at 0.01 level of significance is 2.58. So the calculated value, that is what we obtained, is 2.53. The tabulated value here itself, we can see it very clearly that it is greater than the calculated value. If it is, tabulated value is more than the calculated value, what we defined on the null hypothesis, we have to accept. So the null hypothesis H0 is accepted. That is what we defined, that wheat eaters and rice eaters both are equally popular in that state, that we have to accept it. So what about our graphical representation for this particular problem? Yes, our normal curve is ready, and it is this problem we have taken the two-tailed test. We can see it, that is minus Z alpha to Z alpha. This is the region is accepted, the two sides are rejected. So this is the final output of graphical representation of this particular problem, that is here mentioning accepted regions and rejected region. As this is a problem falls under two-tailed test, two sides of the shaded regions are there, that is minus Z alpha to Z alpha. So we can see it here, the null hypothesis, what we defined, that is wheat and rice eaters both are equally popular, we have taken on the null hypothesis, mentioning capital P equal to 0.5. Yes, it is accepted. Why it is accepted? Now we can see our question. So we can see it here, that is clearly the picture which is given, 1000 people equally popular. The sample is 1000 we have taken. What they asked us to find equally popular, that is the reason we have taken here two-tailed test. Our calculated, the value is 2.53, tabulated is 2.58. So the tabulated or the value here, actually the symbol should be greater than 2.53. So it is, the tabulated value is more, it is accepted. So the next problem is a die was thrown 9,000 times, and of these 3,220 yielded 3R4. That is a die we are throwing 9,000 times. In that 3,220 times we will be getting 3R4. Is this consistent with the hypothesis that the die was unbiased? So the question reading, we are in a position to collect the data, that is n equal to sample size equal to 9,000. Fine. Small, that is sample proportion, that is small p equal to 3,220 divided by 9,000, that is 0.3578. The population proportion, here that is the population proportion, the probability of getting 3 or 4 success, because die, if it is there, a single die which is given, probability of getting 3, what is that, 1 by 6, because the sample space for the single die is 6, 1, 2, 3, 4, 5, 6. 3, the probability of 3 getting is 1 by 6. The probability of 4 getting is 1 by 6. So the both together 3 or 4 is 0.2 by 6, 0.3333. Now capital Q we want it. That is 1 minus capital P. It's nothing but 1 minus 1 by 3, that is 2 by 3. equal 0.6667. So the null hypothesis, that is capital P equals 0.3333, the bias is unbiased. Alternative hypothesis, we rejected, that is not equal two-tailed test taking. H1 is the symbol of alternative hypothesis, that H1 colon P not equal to 0.3333. The dice is biased. So the level of significance alpha equal to 0.05. So the two-tailed test, here it is there. Then the critical, that is the value of Z from the chart we are going to obtain. Alpha equal to 0.05, that is 1.96. So the test statistic for this single proportion is Z equal to small p minus capital P divided by square root of PQ by N. The respective places, we are going to replace the values, that is small p equal to 0.3578 and capital P equal to 0.3333 divided by the denominator. The capital P is taking the value of 0.3333 and whereas capital Q is 0.6667. What about 9? Yes, the 9,000 times we are tossing, that is throwing that die. So the fraction after the calculation, we obtain 0.0245 divided by 0.005, 4.9. From here itself, we can see it very clearly. Before going to the next slide, there is 1.96, that is a tabulated value, it is there. Here, the calculated value is 4.9. The tabulated value should be more. Then we can accept the null hypothesis. But whereas this particular problem, we are not able to accept, we have to reject. The reason is the tabulated value is less. Yeah, we can see it now. So the tabulated value of Z at 0.05 level of significance is 1.96. The calculated value of Z is 4.9. So we have seen it here. The tabulated value is less, that is 1.96 is less than 4.9. Null hypothesis is rejected. Now the graphical representation of this problem is the bell-shaped normal curve, and we have taken two-tailed test, so minus Z alpha to Z alpha. At the point minus Z alpha, the vertical line, and Z alpha, the right side, which is placed because Z alpha is positive, from which the vertical line. So between these vertical lines, the area is accepted region. The two sides, so what I am putting the stars, these two sides are rejected regions. So the final output of the graphical representation of this two-tailed test with a marked arrow mark of accepted and rejected region is, we defined the null hypothesis for this particular problem. Yeah, this is the question we are focusing here. That is capital P equal to capital P population proportion. We accepted that we equal to that 0.333. And the tabulated value we found, which is less than the calculated value. So we are not in a position to accept what we defined on the null hypothesis. So the null hypothesis is rejected. Then alternative hypothesis is dominating. The alternative hypothesis is the die is biased. So the next problem, a random sample of 500 pineapples was taken from a large consignment and 65 were found to be bad. So the sample 500 is there, from which we picked 65. So the proportion was also very, it's ready, 65 by 500. Find the percentage of bad pineapples in the consignment. First, the sample size, which is equal to 500. The sample proportion, the percentage of bad pineapples, that we have to read the question carefully. So that is the reason here 65 which is mentioned as bad. The proportion also, the consignment regarding bad pineapples, they asked 65 by 500. Suppose if they are asking good pineapples, then 500 minus 65, 435 divided by 500 we have to do it. So reading the question, the direct question or indirect question, we have to be very careful. So now the sample proportion, with the symbol small p, the fraction 65 by 500, which is equal to the decimal presentation 0.13. So small q equal to 1 minus p, 1 minus 0.13, which is equal to 0.87. See, here they are asking that only regarding the sample proportion, with help we found q. The limits for population proportion, capital P, the formula we can see it here. That is small p minus 3 into square root of pq by n, or small p plus square root of pq by n. Otherwise, we can tell p plus or minus 3 into square root of pq by n. The respective places, this is the formula, that is to find the limits of population proportion with the help of sample proportion data. So now here the small p is 0.13 minus 3 into, here we can see the square root of 0.13 into 0.87 divided by 500, comma 0.13 plus 3 into square root of 0.13 into 0.387 divided by 500. So the square root, the value actually we can see it here, the change is there. As we calculated, we put it 0.1131 by 500. The same here also. So the final result, we can see it, the calculations part. We obtained 0.085 and 0.175. So the percentage of bad pineapples in the consignment lies between 8.5 and 17.5. That is here what is the data what we obtained, that we found the percentage. So 0.085 the percentage, 8.5, 0.175 the percentage we obtained, 17.5. So in a random sample of 125 cool drinkers, 68 said they prefer thumbs up to Pepsi. Test the null hypothesis, capital B equal to 0.5. Against, here the alternative hypothesis, they gave greater, that is increase, that is right-tailed test. It is mentioned in the question itself. So we must to reject the alternative in such a way, taking right-tailed test because of this notation. Now n equal to sample size equal to here. So here the data we have to see it. Here this is 125. So now the small p equal to sample proportion equal to 68 divided by 125. There is 0.5444. This population proportion is, which is given, capital P equal to 0.5. So capital Q is 1 minus capital P. Why to found this capital P? Because the test statistic, small p minus capital P divided by square root of capital PQ by n, where the capital Q is dominating, that's what we found, the result of capital Q, that is 0.5. So the null hypothesis with the notation H0 colon, that is population proportion, we are accepting as 0.5. Alternative hypothesis, this is a condition given in the problem itself, H1 colon P greater than 0.5, that is right-tailed test. The level of significance, alpha equal to 0.05. If it is not given default in, we have taken 0.05. So the right-tailed test, because of this symbol greater than, here we can see it, the greater than right-tailed test, and it is a one-tailed test. 0.05 what is that? Here 0.05. Yes, fine. Here 1.645 is the level of significance value. So the test statistic is z equal to small p minus capital P divided by square root of pq by n. So the respective places we substituted their values, that is sample proportion as 0.544, population proportion 0.5, and the denominator square root of pq by n. pq are taking the values 0.5 and 0.5, n is dominated by the real number 125. So the fraction 0.044 divided by square root of 0.002. So the square root of 0.002, it is replaced by 0.0447. So finally we obtain 0.9843. Here itself we can declare what we obtained, what we defined on the null hypothesis H naught colon P equal to 0.5. We have to accept or reject. Here the tabulated value is 1.645. That is more than our calculated value. So we can accept our null hypothesis. So what is we discussed, that is written, that is tabulated value of z at 0.05, level of significance is 1.645, calculated value of z is 0.9843. So the tabulated value, which is greater than the calculated value, that is 1.645 greater than 0.9843. So the null hypothesis, what we defined, is accepted. So the normal curve, which is ready, and we selected in this problem the right-tailed test. That is the reason here that the vertical line at the point z alpha, which is drawn, this is the shaded region, which is a rejected region. So more clarity, we can get this final output of graphical representation with the marking of arrows. We can see it clearly. Yes. Now this problem, here strictly it is given greater than. And this is the null hypothesis defined. This question, which made our job very easy, they defined. This is the null hypothesis. You reject in such a way. Yes, it is accepted. So what we defined on the null hypothesis P equal to 0.5 is we have to accept it. So we will move to the next problem. That is experience has shown that 20% of the manufactured product is of the top quality. That is the company, what they are manufacturing. They are telling that 20% we have a top quality. In one day's production of 400 articles only, 50 are top quality. In general, all the products, all the products, whatever they are manufacturing, that is 20% is good top quality. Samples we are selecting 400. In the 400 samples, we are finding 50 are top quality. 350 are not top. Then what we defined this regarding the population, we have to accept or reject. For that, the level of significance is 0.05. Here n equal to sample size 400. Sample proportion, that is 400 samples we have taken, in that 50. So 50 divided by 400 is 0.125. What about capital P? That is a population proportion, 20%, 0.2. How to reject? Here, so the capital P, if it is 0.2, capital Q we found, that is 1 minus capital P, it's nothing but 0.8. So the null hypothesis, the product is top quality. Here, the product is not top quality we have taken. The level of significance is 0.05. That is, for the level of significance 0.05 for the two-tailed test, the tabulated value is 1.96. The test statistic z equal to p minus capital P divided by square root of pq by n. Suppose in this particular problem, here instead of not equal, if you take, because this is population proportion 0.2 and 0.15 is the sample proportion. So the sample proportion is, if you are taking less, is it possible we can go for that is rejecting another way in this particular problem? Yeah, it is possible in this problem in another way, that is 0.15, the sample proportion, which is less than the population proportion. We can go for left tail also. So now we have taken here the two-tailed test, that is small p 0.125, whereas capital P is 0.2, divided by capital P is replaced by 0.2 and capital Q 0.8 divided by n is 400. So the numerator, which is dominated by minus 0.075 divided by square root of 0.0004. The fraction what we obtained is minus 0.075 divided by 0.02 equal to minus 3.75. So mod z we have to find 3.75. So this complete the points, 4 points, null hypothesis, alternative, level of significance, the test statistics regarding two-tailed test we have written. That's what. Now suppose the same problem, if we have taken left tail, what will happen? Here the tabulated value that differs. One tail, that what is a 0.05, one tail is 1.645. That will be placed here. Whatever it is there, the calculated value, if it is 3 more than, it is compulsory, the null hypothesis is rejected. Why? Because the critical value of z, the table we have seen, maximum it is 2.58. So more than 3, closing our eyes, we can say the null hypothesis, whatever it is there, defined. If calculated value is crossing more 3, then we can reject it. So that the presentation we can see it. The tabulated value of z at 0.05, level of significance is 1.96. Calculated value of z is 3.75. So the tabulated value is less than calculated value, and 1.96 we are saying it is less than 3.75. So the tabulated value is less. That's what the null hypothesis is rejected. So we can see here, this is the basic diagram, and here minus z alpha to z alpha, it is a accepted region. This is the shaded region. This is the graphical lines, that is the two vertical lines. One is left side from minus z alpha and another one the right side at z alpha. So the two-tailed test, the graphical representation, and yes, in this question they didn't give anything how to reject anything. So in general, the statement they're given, we have taken the two tails, that is we defined their top quality and rejected not top quality. That's what we defined it. But if it is possible, comparing the sample proportion and comparing sample proportion and a population proportion, we can go for one-tailed test also. As the tabulated value is less than the calculated value, the H naught is rejected. So what we defined on the null hypothesis, they are top quality, it is wrong. That is, they are not top quality. So the next problem, in a sample of 500 from a village in Rajasthan, 280 are found to be wheat eating people and the rest are rice eaters. Can we assume that the both articles are equally popular? So they're telling 50-50 percentage. That's what the population proportion ratio which is given. If it is equally alternative, we can tell two-tailed we can go. So here the level of significance alpha equal to 0.01. What is the sample? Yes, the sample size is 500. The ratio, 280 are of wheat eaters. So the wheat eating, the proportion is 280 divided by 500. Very clear picture about this problem. So n equal to sample size equal to 500. So sample proportion of wheat eaters, 280 divided by 500 equal to 0.56. Capital P equal to population proportion, that is 0.5. Capital Q, it's nothing but 1 minus capital P, that is 0.5. The null hypothesis, that is H naught colon, capital P equals 0.5. Both the articles are equally popular. That is wheat and rice eaters. We are rejecting. No, they are not equal. Level of significance 0.01 specifically which is given in the question. Yes. Now it's a two-tailed test. Here the 0.01, that is the tabulated value is 2.58. The test statistic, that is z equal to small p minus capital P divided by square root of pq by n. So we have to replace it. That is the sample proportion is 0.56 minus capital P, it's nothing but 0.5. Divided by square root of pq, 0.5, divided by n, that is 500. So the numerator is 0.06 and the denominator is square root of 0.0005. The fraction is 0.06 divided by 0.022. The final result of this calculating the test statistic, the result is 2.72. So mod z equal to 2.72. It is not affecting already. We got it the positive only. If it is negative, we have to be very careful. So whatever the tabulated value, calculated value, we are taking modulus of. So here the calculated value is 2.72. So the tabulated value of z at 0.01, level of significance is 2.58. Calculated value of z is 2.72. Tabulated value which is less than the calculated value, that is 2.58 is less than 2.72. The null hypothesis, because the tabulated value which is rejected, it is less than the calculated value. Here it's very clearly the basic normal curve and it is the z alpha and minus z alpha, the vertical lines between accept region, the other two-tailed here and here, they are the rejected regions. So we can see very clear this graphical representation of the two-tailed, and what we defined, we can go back to our question, that is here. Equally popular. That's what we have taken the two-tailed test and we rejected such a way, not equal. We are not in a position to accept the null hypothesis because of this calculated value. Tabulated value is less. We have to reject the null hypothesis. Rejected. So alternative hypothesis is dominating. What that alternative hypothesis? The articles wheat and rice eaters are not equally popular. So the next one, in a hospital, 400 females and 520 male babies were born. in your wake. Do these figures confirm the hypothesis that males and females are born in equal number? Then we will tell we can define the null hypothesis, which is equal to alternative hypothesis not equal. Yes, n equal to sample size. What are the samples? Both male and female babies. Put together 1000 samples. So the small p, the proportion we are taking. Sample proportion of females born. Here, why we can't take a male born? Yeah, we can take it that way also we can. Here 480, what we are taking? That to be written here. So sample proportion of females born, that is 480 divided by 1000, 0.48. So the capital P, that is the population proportion, 50%, 0.5. Capital Q, 1 minus capital P equal to 1 minus 0.5, which is equal to 0.5. The 5 points. The null hypothesis. H naught is a symbol for the null hypothesis. Capital P, population proportion. We are telling both male and female, they are born in equal number. We are rejecting no, they are not born in equal number, two-tailed test. It is not given the level of significance. Default we have taken alpha equal to 0.05. So the tabulated value is 1.96. The test statistic is z equal to small p minus capital P divided by square root of pq by n. The substitutions, that is small p is 0.48, capital P 0.5 divided by square root of 0.5 divided by 1000. So the denominator, the calculation is square root of 0.00025, whereas numerator is minus 0.02. The fraction what we obtained after the calculations, minus 0.02 divided by 0.0158, which is equal to minus 1.265. So mod z equal to 1.265. So here, if you are not taking modulus, which will affect the entire result, the output of the solution of the problem. So the tabulated value of z at 0.05 level of significance is 1.96. Calculated value is 1.265. That's a tabulated value which is greater than the calculated value. There is 1.96 which is greater than 1.265. The null hypothesis, what is defined, we have to accept it. The bell-shaped normal curve, and in this we have selected the two-tailed. The graph here, the particular is minus 1.96 to 1.96. This is the regions, that is the rejected regions. So it is very clearly, it is given the graphical representations with accepted and rejected regions. Yes, they are born, males and females, born in equal number. So that's what we defined the null hypothesis, capital P equal 0.5, equal number, alternative hypothesis, taking the two-tailed test, not equal. So here the not equal is selected. We have to accept it because the tabulated value is more. So both male and female, they are born in equal number. We can declare the result. So the next one is a manufacturer claimed that at least 95% of the equipment which is supplied to your factory conformed to specification. An examination of a sample of 220 pieces of equipment received 80 were faulty. test the client at 0.05 level. So the total complete the 95% they are fit for the specification. Sample we are taking 220 pieces in which 80 were faulty. So n equal to here the total number of equipments 220. What is the faulty one? Here 80 divided by 220, it's 0.4 and the population proportion is 0.95. So the capital Q equal to 0.05. The null hypothesis that what we defined is H naught colon capital P equal to 0.95. Here we noticed here that is capital P. Here we have taken the left-tailed test 0.95. The reason is the sample proportion which we are taking which is less, and the level of significance we have taken the by default 0.05 and the tabulated value is 1.645 because it is a one-tailed test. The test statistic is P minus capital P divided by square root of PQ by N. The particular places 0.4 and 0.95 they are replaced for small and population proportions. Capital P and capital Q they are replaced by the value 0.95 and 0.05. N is 200. The fraction what we obtained is minus 0.55 divided by 0.0154, which is equal to minus 0.0085. So the modulus of minus 0.0085 equal to 0.0085. So the tabulated value of Z at 0.05 level of significance is 1.645. The calculated value of Z is 0.0085. Tabulated value which is greater than the calculated value. So 1.645 which is greater than 0.0085. The null hypothesis is accepted. The normal curve under the area, the total area which is 1, and we have taken the two-tailed. Here in this particular problem, we have taken the left-tailed test. It's not two-tailed, left-tailed. That is minus Z alpha. This complete region. What is that? Here's the right side to this particular point. Everything is accepted. This is the region is rejected. That's what we can see it more clearly in this graphical representation. The clear picture, the output we will be getting in a better way. Here we'll go back to the problem. Here we have taken that is the 80 divided by 220 equal to 0.4. This comparison also we can made it. We selected here the left tail we selected. First we accepted that P capital P equal to 0.95. Null hypothesis we defined. We rejected selecting the one-tailed test, that is a left tail. Why we accepted? Because the tabulated value is more than the calculated value. That's what the deal what we defined on null hypothesis H0 is accepted. We will come to a conclusion of this topic, test of significance for single proportion. What is population? What is sample? What is the difference between population and sample? Clearly we discussed the sample is a subset of population. The complete sampling theory, there is a relationship between population and samples. Critical value of Z, yes, the tabulated value of Z. With that, we are able to take the decision what is defined as a null hypothesis to accept or reject. Test statistic, small p minus capital P divided by square root of PQ by N. The entire video lecture we discussed different problems. Yes, These are the problems we discussed. Different graphical representations. So this is one of the graphical representation. This is the second one. Third graphical representation. The fourth graphical representation. Here the picture very clearly why it is accepted, why it is rejected. And then next we moved. This is here the graphical representation, why it is accepted also, the data which are given. And move to the next problem. Here it is a null hypothesis rejected. Next to the problem, many number of problems we discussed in this video lecture. The next, the graphical representation with a two-tailed test. Then finally, we concentrated the left-tailed test. So the complete knowledge about the test of significance for single mean, which is discussed in this complete the video lecture. Thank you very much to you all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.